All right, welcome to our today's class. In today's class, we're looking at the above question. It says we should show that partial derivative of p all over the partial derivative of t, keeping v constant, is equals to 1 over t into p plus the partial derivative of v of u all over the partial derivative of v keeping t constant. And how do we prove this? Let's get started. All right, the solution now. Solution to this. All right, the first thing we are going to do is, from the first law of thermodynamics, we know that the q is equals to the u plus p dv. And we also know from the second law of thermodynamics that the q is equals to t ds. So from here, I'm going to substitute t ds for the q here. So if I do that, I'm going to have t ds to be equals to du plus p dv. All right. So the next thing I'm going to do is I'm going to make du the subject here. So if I do that, du will be equals to t ds minus p dv. All right. Now the next thing I'm going to do is I'm going to divide through by dv. All right. So let's divide through by dv. Means we are going to have du all over dv is equals to t ds minus p dv, everything all over what? All over dv. All right. So if I do this, I'm going to have this in form of, I'm going to have this in, all right. So I'm going to have this in form of this. So we can write this as du all over what? All over dv will be equals to, now you know from our elementary mathematics, we can split this division. So we are going to have it as t ds all over dv minus p dv all over what? Dv. And you know that dv here will cancel out dv here. So we are going to be left with du all over dv equals to t ds all over dv minus p. All right. Now we want to write this in form of what? Partial derivative by keeping what? T constant. How do we do this? Now, the reason for this is because we have everything, we want to get this t that is in our answer here. All right, now. So if I want to do that, I'm going to turn this to partial derivative of u all over the partial derivative of v, then keeping t constant, which is going to be equals to t into, then if I'll turn this to partial derivative, then I'll keep my t constant as well. Partial derivative of s all over the partial derivative of v, keeping t constant minus p. All right. Now you are going to recall carefully that from Maxwell equation, from Maxwell equation, from Maxwell equation, we are going to recall that partial derivative of x all over the partial derivative of v, keeping t constant, is nothing but the partial derivative of p all over the partial derivative of t, partial derivative of p all over the partial derivative of t, keeping v constant. We've already established this from our first lecture under what? Under thermodynamics relation. All right. So now I'm going to replace this with this. So it shows that my equation here will become the partial derivative of u all over the partial derivative of v, keeping t constant, to be equals to t into partial derivative of p all over the partial derivative of t, keeping v constant minus p. All right. Now The next thing I'm going to do is I'm going to move this minus p to this other side, which will becomes what? Positive. Then we can therefore say t, into the partial derivative of p all over the partial derivative of t, keeping v constant, is going to be equals to the partial derivative of u all over the partial derivative of v, then keeping t constant plus p. All right. Now the next thing is I will divide both sides by what? 1 over t. Sorry, I'm divide both sides by what? By t. All right. If I divide both sides by t, I'm going to have this as t into the partial derivative of p all over the partial derivative of t, keeping v constant all over t, to be equals to the partial derivative of u all over the partial derivative of v, keeping t constant plus p all over what? All over t. So t here will cancel out t here. Then I'll be left with what? I'll be left with the partial derivative of p all over the partial derivative of t, keeping v constant, which will be equals to, now what is here? This I can write it as 1 over t. Yeah, so it's going to be 1 over t into the partial derivative of u all over the partial derivative of v, keeping t constant. Let me open a big bracket here, plus a p. So this is already the proof, but in order for us to write it in a more form, here they wrote p plus this, and here we are getting this plus this, which is also correct. 1 plus 2 is the same thing as 2 plus 1, but let's write it in a more form. So we can say that therefore the partial derivative of p all over the partial derivative of t, keeping v constant, is nothing but 1 over t into p plus the partial derivative of u all over the partial derivative of v, keeping t constant. So this is the proof. And mind you, to keep this, we are still going to use this in our subsequent video. Thanks.